Hello everyone. So I promised you I would do a domain and range problem from your homework. So I'm going to go ahead and do this one. All right. And the thing that we have to remember here are the definitions of what domain and range actually represent. So the domain, okay, are going to be all the available x values. Okay. So for example, if you had like a function, let's say f of x, and let's say this function was 1 over x plus 1, okay, then your domain will be all of the values of x such that when you substitute them in for x, you're going to get some sort of output that we call our range, okay? So an easy way to think about this would be like if you had like a machine, all right, or better yet, I think a better way to think about this is a calculator. So let's say you had a very, very, very special calculator. And the only thing that this calculator knew how to do is 1 over x plus 1. Now, I put parentheses in for the x, all right? But this calculator, this is the only thing it knows how to do. So if you typed in 1 into the calculator and you hit enter, this 1 would go right here. And then the calculator would display 1/2, okay? Likewise, if you substituted in, let's say, a 0, okay, then the 0 would go right here and the calculator would display 1 over 1 or just 1 itself, all right? So this is how functions and domains work. Now, there is one situation with this specific example, f of x equals 1 over x plus 1, that we need to avoid. And that is the value -1. Because when we take -1 and we type it into this very special calculator and we hit enter, the -1 falls down into the denominator here, okay? And then your calculator is going to say undefined, all right? And the reason for that is -1 plus 1 is actually 0, and 1 divided by 0 is undefined. So domain will be all of the available x values that you can use, all right? So I'm just going to go ahead and erase this, and we're going to define range here real fast. All right, so range is going to be all of the outputs after the domain is used. Now, like I said, this is not going to be like, you're not going to see these two definitions anywhere in a book. This is just me talking to you, okay? But basically, when we talk about domain and range, and now more specifically range, what we were thinking about are what are the y values, okay? So like, for example, let's say we have a function, f of x equals x to the second power, all right? And we were to go ahead and create a table of values, all right? And let's say I use the values -2, -1, 0, 1, and 2, okay? Notice that my x values are my domain, and my f of x values, we can think of them as y. This is going to be my range. So what I'm interested in for the range is after I've used my domain into the function, or after I used an x value into my function, the output is going to be its range, okay? So like, for example, if we take -2 and we substitute it into our function, we're going to get +4. And then I'm going to fill out the table. If we use -1, we get +1. If we use 0, we get 0. If we use 1, we get 1. And if we use 2, we get 4, okay? Now, this is the algebraic approach to this, all right? Trying to find domain and range, okay? And you could totally do algebra using domain and range anytime you want. But there's a problem with using just strictly, there's a problem with just strictly using algebra, which is how many x values do you need and how many y values will you get to satisfy the domain and range? Because one thing you got to remember here, okay, is that what I have written up above, okay? And let me get out my highlighter here so you can actually see it. It's these two words right here, or this word that's repeated in both definitions. It's all of them. And sometimes when you are dealing with graphs of functions, you can have an infinite amount of x values and an infinite amount of range values. So what we'd like to do is when we start to learn about domain and range and how it actually works, all right, we like to look at a graph. So notice here on the left-hand side, I have a graph. And what I'm going to do real quick is just erase everything. Okay, so I erased everything, and I'm going to zoom in on this graph for us here, okay? I know there's a bunch of questions that we're going to answer, but we'll answer them in a minute. First thing we got to do is we got to look at what we call the behavior of this graph, okay? Now, there is some things going on. First, we know that the horizontal axis is x, and what we noticed here is that this graph going from left to right literally stops at negative 2 pi and positive 2 pi. You can't go any further to the left of negative 2 pi, and you can't go any further to the right of positive 2 pi. That is our domain. So our domain for this problem right here is going to be brackets, because you're allowed to include the endpoints because they're solid dots. So our domain is going to be negative 2 pi to positive 2 pi. Okay, and that's what the domain is. Now, let's look at our range. Well, our range, remember, are going to be all of the y values. Okay, but if you notice, the highest that this graph gets is this blue line right here. Now, it doesn't matter what x value you're at. For example, negative 2 pi has an output of 1, 0 has an output of 1, and positive 2 pi also has an output of 1. So this is the highest that the graph gets. In other words, this is the largest y value. And also, when you look here, this is going to be our smallest or our lowest y value. So at this point right here, this is negative pi, comma, negative 1. And this is positive pi, comma, negative 1. But regardless, that's the lowest y value. So our range, okay, our range is going to go from negative 1 to positive 1. And you can use brackets because we have solid dots at those points. So when we think about domain, and let me write this in the same color here. When we think about domain and we think about range and we're looking at a graph, all we're really asking ourselves for domain is how far to the left and right can I go? That's the x-axis. And for the range, it's going to be how low and how high can I go? And that's going to be the range or the y-axis. All right? So we already answered two of the questions in the homework. This is G and H respectively, but I'm going to go back through and I'll answer all of them because I know there's like A, B, C, D, E, F, G, and all that other stuff. All right? So let me go ahead and erase everything, and we're going to answer every single question one by one so you can see how this works. All right, I'm back, and I erased everything. So, part A. Part A says find f of 0, okay? Now, when we see f of 0, remember, that number right here, let me draw a little bit better arrow. That is our x value. That's our domain, okay? So what we want to know is, when x equals 0, what is f of x equal to? So I literally come over to my graph. Right here is where x equals 0. And notice the point is going to be 0, 1. So f of 0 equals 1. So there's our first example right there. Okay? Now, your problem may be a little bit different, but the idea is still the exact same. You go to x equals 0, and then you go to your graph, and you tell me what is the y value right there. All right, so let me erase. Let's go ahead and do part B. Part B is find f of pi. Once again, what this is really saying here is when x equals pi, what is f of x equal to. All right, so we come to pi, which is going to be right here. That's where the x-axis is. That's pi. And notice, here's our graph right there. That's the point. So this is going to be the point pi comma -1. So when x equals pi, what is f of x? Well, f of x equals -1. So there's part B. Part C, let me erase. Part C is asking, find f of -pi. Okay, once again, when x equals -pi, comma, f of x is going to equal, well, over here is -pi, so we put a little dot right there, and that's the point -pi, comma, -1, so this is going to equal -1, all right? So when x equals -pi, f of x equals -1. Now, for D and E, they're asking a little bit of a different question, so let me go ahead, erase, and let me set this problem up for us, okay? Okay, I am back, and I wrote out the problem. So it says, find the values for x when f of x equals 0. So what this question is saying here, they're saying y equals 0, what x values does this occur? All right, or what are the x values where y equals 0, okay? So remember, and this goes back to like this goes back to like when you were introduced into linear equations. When y equals 0, you are at an x-intercept. All right? So remember, x-intercepts always look like this. They always look like that. X is going to be a number. Y, though, is always going to be equal to 0. So that is going to occur right here, right here, right here, and right there. So there are 4 values of x when y equals 0. The only thing we got to do now is just figure those out. And it's actually a lot easier than you think. So if you look at the graph that we have, I'm going to zoom in for us. If this value right here is pi, which it's already labeled, and we know right down here, this is x equals 0, and this number is in between them. In fact, it's halfway in between them. Then that is going to be pi over 2. It's literally halfway in between 0 and pi. Now, that's going to make this 3 pi over 2. All right, so how do we find this value right here? Well, it's actually much easier than you think, so let me show you, okay? So, for example, I'm going to draw like a little number line down here. All right, notice I'm going to draw it directly underneath. So I know this is 0, this is pi over 2, this is pi, this is the one we were looking for, all right? So I'll put a question mark. And then here we have 2 pi, all right? Well, if you go from left to right, okay? Notice that jump or that distance from pi to like what we're looking for is actually just pi over 2, all right? So all we have to do is take pi plus pi over 2 and just add these together. So notice that when you have fractions, you need a common denominator. So we're going to make this 2 over 2. So that's going to give me 2 pi over 2 plus pi over 2. And since these terms in the numerator are like terms now because they both contain a pi, all right, you can actually add them together to give you 3 pi over 2. So this is going to be 3 pi over 2. And that's how I got that. All right. Same thing occurs on the left-hand side. So on the left-hand side, this is going to be negative pi over 2. And then this value right here is going to be negative 3 pi over 2. So when we ask the question, find the values for x when f of x equals 0, and what they're really saying is, okay, y equals 0, what x values does this occur at? Well, it's going to occur at x equals negative 3 pi over 2, comma, negative pi over 2, comma, pi over 2, comma, 3 pi over 2. And that is exactly how you would type in the answer in WebAssign, because they ask you to not only find the values, but then in parentheses, it'll say, or it doesn't, it says, enter your answers as a comma separated list. If there are no answer, then you enter none. Well, this is a comma separated list. Now, what's excellent about this, if you understand part D and what it's asking, and remember, I said earlier, what it's really saying is find the x-intercepts. Part E literally says find the x-intercepts. All right? And that answer is literally right here. So it's directly above us. So I'm just going to go ahead and just copy and paste. All right, and just write in black x equals, and that's the answer for part E. So that's simple enough. It's literally just the same thing as part D. All right. Now part G. Actually, you know what? I'm going to pause the video and erase. Okay, I'm back. Part G. Oh, no, I'm sorry, part F. I almost skipped F. F says find the y-intercepts. And we have to remember, at a y-intercept, x is always going to be equal to 0. So right here is where x equals 0. Right here is the y-intercept, and that is 0, 1. So when it says find a y-intercepts, y equals 1. There's your answer for F. And then, like I said at the very beginning of this, for G and H, G is find the domain. And we already labeled the domain. It goes from negative 2 pi to positive 2 pi with brackets because you have these solid circles, okay, at either ends of the interval. And finally, part H is find the range. And the range goes from negative 1 to positive 1. And you can include brackets for that because if you notice at these values, it's a nice smooth curve. There's not like a hole or anything like that. So you can include those values. And that is how you do this problem. So I hope this kind of cleared the error or got some rust off when it comes to finding domain and range. All right. Domain and range is really easy once you understand what they're really asking for. Okay. So if you have any questions, let me know. Other than that, good luck. Enjoy.